I am Dr. PSV Shanmukhi, Associate Professor, Department of Physics, Aditya University. Now I am going to explain about the grating spectrum. Same. At the end of this lecture, the students will able to understand the grating instrument. What is a grating, and what we can understand from that grating. The students will able to understand, and they will also learn about the grating spectrum. So, coming to the first one, what is a grating or what is a plane transmission grating? Generally, a plane transmission grating is an optical instrument which is used to study the diffraction of light. To study the diffraction, there is one condition: the width of the slit must be comparable to the wavelength of light. Then only we can observe the diffraction pattern, means we can observe the alternate maxima and minima. So, the the very essential condition is the width of the slit must be comparable to the wavelength of light. Of course, here ordinary windows or slits are not at all suitable to study the diffraction due to even ordinary light or the visible light. That is why we will go for an optical instrument. It is called grating. Grating is an optical instrument that is used to study the diffraction of light. So, generally a grating is made up of either glass or plastic. It is simply a glass plate or a plastic. In general, we go for glass material. It contains several lines. They are called actually rulings of the grating. You just say this is the plane transmission grating given. Generally, with our eye, we cannot observe. There are so many lines drawn on this one. Several lines are drawn. They are called rulings of the grating. See, actually a sophisticated grating contains nearly 15,000 lines per inch. There may be 5,000 lines, 10,000 lines, or 15, 20, even 25,000 lines also per inch, 2.5 per centimeter. A sophisticated or costly grating contains nearly 15,000 lines. So, as more number of lines are there on the grating, cost goes on. Anyhow, it has so many features that what we are going to discuss now. Except the rulings, actually the remaining part acts as the opaque to light. Suppose these lines are acting like rulings of a grating. When the light is passing through this one, here you observe there are 15,000 lines per inch. So, 15,000 lines per inch, 2.54 centimeter. What is the separation of the slits? 2.54. 2.54 divided by 15,000 centimeter we get. That means nearly 10 power of minus 4 order of that one. So, it is nearer to the wavelength of the visible lights. That is why this plane transmission grating, when the light is passing through that one, then through the slit the light passes, it will produce this kind of diffraction pattern. So, anyhow, what is a grating spectrum? Here a diffraction grating is taken, you observe here, and through the slit means the light is passing through the diffraction grating. A diffraction grating can be considered as n parallel slits, n parallel rectangular slits. There is a Fraunhofer diffraction due to single slit, double slit, and n slits case also. Here this is called n slit diffraction, n slits diffraction in case of Fraunhofer. So, anyhow, after passing through the slit, the light rays are different. Actually, white light is passing through the slit. Say, white light is not said to be the monochromatic. It is not the monochromatic light. It is the combination of 7 colors. What are the 7 colors? VIBGR: violet, indigo, blue, green, yellow, orange, red. 7 colors are there. Then, when the light is passing through that one, what happens? We get the diffraction pattern containing this kind of central maximum and several peaks like this. This is actually called one spectrum, and you go somewhere, there also several peaks you will get. This is called second order. Say this is k is equal to 0 called central spectrum, and k is equal to 1 first order spectrum, k is equal to, this also left side, k is equal to 1 first order spectrum. Again you go somewhere, k is equal to 2 second order spectrum, like that you will get different spectra. At each case you will get the white light, on either side of the white light you will get the colors VIBGR violet to red, and left side also violet to red color you will find. So, what is the use of this grating actually? It is acting like a dispersing agent. What is meant by dispersion of light? When the white light is passing through the, say you know one thing, when the white light is passing through the prism, then it is split up into 7 colors VIBGR. So, instead of using the prism, you can use the grating as a dispersing agent. What is the use of that one? The dispersive power of the grating is very high. It is very higher than the dispersion of the ordinary prism. You can split the light into different colors or different wavelengths. That is the advantage, one of the applications of this diffraction, nothing but the grating. So, in the grating spectrum, so there is one maximum condition that is given by E sin theta is equal to K lambda. E is the separation of the slits, and K order of the spectrum, lambda wavelength of light that you are using there. K is the order of the spectrum, just now I have explained. So, this is the central spectrum, and go for the first order left side, right side, first order left side also. Anyhow, and again you go to long distance, K is equal to second order spectrum also will get, but that becomes very blurred. Why? Because, so the intensity decreases while going from center to outward in case of diffraction, that what we know. That is why the central spectrum having some intensity, and going to first order intensity little bit decreases, but separation will be more. Again you go, why? Because as theta is increasing, separation increases. That what I am going to explain now. Just observe, say the dispersive power, this is actually E sin theta is equal to K lambda, that is called grating equation. This is the condition for the principal maximum, or this is called grating equation. E sin theta is equal to K lambda. Suppose you differentiate this equation not with respect to anything, simply take the variation in this one. E sin theta means E is constant, differentiating sin theta you will get the cos theta into d theta. K lambda, K is constant, lambda means K into d lambda we get. Now, I just write d theta by d lambda or delta theta by delta lambda. What we get here? K by E cos theta. This delta theta by delta lambda is called dispersive power of the grating. How far the instrument deviates the wavelengths or disperse the colors, that is called dispersive power of the instrument. Here the dispersive power delta theta by delta lambda, it is given by K by E cos theta. Here we can understand two interesting points. This dispersive power is directly proportional to K. K is the order of the spectrum. Just now I have explained, just while going from center to outward, the intensity of the diffraction pattern decreases. Understood? That is why this is the 0th order and this is the first order. You will go to this one second order, this side also first order, second order. If you go to more order, K increases, the dispersive power also increases, but there is a drawback here. As the dispersive power is increasing with K, but the intensity decreases, becomes somewhat blurred there. Less intensity, dull light you can observe. That is why this is not the required feature for us. So, hardly we will go for the first order. And there is another interesting feature here, delta theta by delta lambda is inversely proportional to E. What is that E? E is called separation of the slits. As the separation, you observe in case of this one, this is the grating element or separation. As the separation is increasing, what happens? The dispersive power decreases. As E is increasing, dispersive power decreases. E should be small. When E becomes small, if more number of lines, instead of 15,000 lines, if 20,000, 30,000 lines are there in 1 inch or 1 centimeter, more number of lines are there, E decreases. So, if more number of lines are there, separation decreases. As the separation is decreasing, then dispersive power delta theta by delta lambda increases. So, our required feature is E should be very small. That means the number of lines should be more. Even though the grating is costly, more number of lines, drawing more number of lines goes to a little bit costly instrument it is. That is why no problem. If E is decreasing, more number of lines are there, then E decreases, then the dispersive power increases. So more separation you can find here, automatically we can deviate all the wavelengths very clearly, very clear picture we get. That's why we will go for the first order, and we take more number of lines must be there on the grating. So this is the required feature for us, the dispersive power. So what just we discussed here is the grating. What is the grating instrument? Grating is an optical instrument which is used to study or used to get the diffraction pattern due to the light. And what is the grating spectrum? After passing through the grating, the white light gets separated into the 7 colors, and to get more separation, we need more number of lines on the grating, so that the grating element decreases, and more number of lines are there, say more dispersive power we get. So the grating spectrum also we have discussed here. Okay, thank you very much.